we're going to talk about the basics of graph theory, and graph theory is not your normal graphs that you're used to, x and a y-axis. It's going to be a completely different type of graph, so we've got a lot of vocabulary to talk about first. I have an example of the graph at the bottom of your screen here. This picture for your graph consists of points, and points are called vertices, and the lines connecting those vertices are called edges. Edges can be straight or curved or looped, like you see right here at B. This is a loop. It's a loop. Occurs when a vertex is connected back to itself. It's still an edge, but it is called a loop as well. So you see we have some straight edges and we have some curved edges. We have some vertices that are off to the side by themselves, and that's fine too. It's still a part of the graph. Some other terms is adjacent vertices. Adjacent vertices are any vertices that has an edge joining them. So for example, in this particular graph, vertex A and vertex B are adjacent because they have an edge connecting them, as well as D and E, E and B, B and C, C and D, and so forth. There's several examples of adjacent vertices here. Adjacent edges share a common vertex. So some examples of adjacent edges in this graph that's listed is the edge DE is adjacent to the edge EB. They're adjacent because they share the common vertex E in this particular graph. Another set of adjacent edges would be AD, edge AD, and edge DC. They are adjacent because they share the common vertex D. Some additional notes about this graph is just because these edges intersect here does not mean that we have to have a vertex there. Also, vertex F, because there are no edges connecting vertex F, it is called an isolated vertex. And because there are multiple edges between C and D connecting them, we just say that C and D have multiple edges. Connected graphs. A graph is connected if there is a path between each pair of vertices. Or another way to say that is that you can get to any point on the graph from any of the vertices. So these are examples of connected graphs here. Every vertex is accessible through edges. There may not be a direct path to that vertex, but you can access any of those vertices. These are all connected graphs. Some examples of not connected graphs are whenever there is not an edge between vertices and they leave them isolated or disconnected. So these are examples of not connected graphs. Another important vocab term that you need to know is a complete graph. A complete graph is graphs in which every vertex is adjacent to every other vertice. Or another way of saying that is there is an edge from every vertex to every single one of the other vertices. So these are examples of complete graphs. There's an edge connecting every vertex to every single one of the other vertices. That makes it a complete graph. So these are all examples of complete graphs. Lastly, for this video, describing vertices and edges, we use set notation in order to describe them. We list all the vertices inside brackets to label all the vertices, and we describe edges the same way. We describe edges based on the vertices that connect them. So in this particular graph, we have 6 different vertices, A through F, and we have 1, 2, 3, 4, 5, 6, 7, 8 different edges. If you notice vertex C and D have multiple edges, you have to list those twice. You have to list it as CD and then again as DC to denote that there's 2 different edges between those vertices. The loop here from B back to B is labeled BB to denote that it is a loop and there is an edge there. So what I want you to do now is to describe this graph.